So my name is Hazel Weekly. This is Sandeep, and today we're going to be going over systems thinking with poisoned systems. So I am a fellow of the Nivenly Foundation. I have thoughts, lots of thoughts. They never stop thinking, they never stop thinking. And also, I am part of the Deaf and Hard of Hearing Working Group at the CNCF. Because, fun fact, neither of us can hear. So if you have any questions, that sucks. Just kidding, we have Slack. And so here's Sandeep.
Hello everyone, I'm Sandeep. I'm a lead software engineer at Gen, formerly known as Northern LifeLock. Unofficially, I have been an SRE for as long as I can remember, although I don't have the official title of an SRE. So, Katie Milder, she said yesterday that I'm the kind of person who just can't help myself from running towards a fire. She spoke this in yesterday's plenary session, and I could totally relate to it because I'm the kind of person who runs towards all the fires of Kafka, Elasticsearch, Cassandra. You name it, 2M, 3M, 4M, I have been done that and done that. And I also had to run to catch a plane so that I could make it to this conference. And this is my first time speaking at SREcon, and I've just been overwhelmed with the love that I've gotten here. It's a beautiful conference, an amazing audience, and I wouldn't be here were it not for my brilliant co-speaker, Hazel. So let's get started. So today we are here to talk about systems thinking with poison systems. Because as SREs, we just don't deal with broken systems. We deal with systems which are also misleading. We have all been there, debugging an issue in production, where the monitoring dashboard says one thing, the log says something else, and the root cause is hidden behind layers of automation. You have been there, you have experienced it. Now, what I want you to imagine is that you throw AI into this mix. So AI promises to help us understand our systems better, detect anomalies, and even predict failure. But what if the AI is trained on incompatible, flawed, and poisoned data? Will it help or will it lead us astray? So AI is often described as a garbage in, garbage out. But when a well-tuned system starts relying on AI, do we get chaos or a revolution or something in between? So that brings us to the first point, AI as a flawed tool of understanding. So AI is increasingly being used in observability, in incident monitoring, response, and troubleshooting. But there is a fundamental issue. AI does not actually understand systems. It finds patterns based on historical data. So as SREs, we use tools to help us monitor, debug, and optimize systems. But AI-powered tools introduce a new challenge. They just don't reflect reality, they shape it, and it can sometimes be actually misleading. So AI models, they learn from data. Now what happens if the data is flawed, whether through biases, inconsistencies, or intentional manipulation? So if the data is flawed, the AI's conclusions will also be flawed. And when we blindly trust those AI's flawed outputs, we end up making bad decisions. AI, as it turns out, does not understand the systems the way we humans do. Instead, it just makes probabilistic guesses based on past data, which may not actually align with our SRE needs. So, in today's talk, we will explore three key issues that highlight AI limitations. The first one is data poisoning, the second one is AI bias, and the third one is AI-related de-skilling. So let's come, what is data poisoning? So as I said, AI relies entirely on historical data. So if the data is incorrect, incomplete, tampered with, so that is known as the data poisoning. And the data poisoning can happen in two ways. Unintentional poisoning, you mislabel a flag, a system that is supposed to be marked up, you accidentally mark it down while training your data. So that is an unintentional. And intentionally, a malicious attacker can actually manipulate the training data and the model misclassifies the data. So the problem that is that once the data is poisoned and an AI model is trained on that poison data, then whatever is output, that output is again fed into further AI model, then you know what it leads to. It makes things worse. It goes into like a cycle of poisoning. And if the AI system has never seen a real failure, it might assume that this failure never exists in the first place. And if that happens, it could actually miss a real critical failure. And even when AI is not being actively poisoned, it can make flawed assumptions about the world, which brings us to AI bias. So AI bias emerges when models reinforce patterns in training data without questioning whether the training data should use, whether those patterns are fair, representative, or correct. So since AI learns from historical incidents, but history doesn't always reflect the real world complexity. So what happens is that the AI-powered remediation systems, they could prioritize past solutions, even if they are wrong or they are suboptimal. Or AI could suggest that because of a CPU spike, you restart the service to fix the CPU spike. But when you actually restart the service, it could lead to a complete outage. And AI might under-prioritize newer failure modes because it hasn't been trained on them. And the new infrastructure, for example, like the Kubernetes upgrade may break in ways because AI isn't trained for it. So, summing up, AI is not a reliable decision maker. It is a tool that needs constant tuning and human oversight. And ironically, instead of making the troubleshooting easier, it could sometimes make it more complex.
So let me start with a story. Once upon a time, and by once upon a time, I mean the time period has been changed to preserve the innocent. I was tasked with troubleshooting and seeing and figuring out how to take something and it just wasn't working. It was a little tricky and involved tools that nobody on the team was quite familiar with or really knew what to do. And then so I was like, how do I actually accomplish this with this tool? Like, how do I do this? And I asked a coworker for help. And I asked him for his advice. And he said, oh, what if you tried this command line flag argument? And my first immediate thought was, that's a weirdly convenient command line flag argument. It's almost like it does exactly the thing that I needed to. So I tried it. And then the CLI spits out an error and says, this flag is not recognized. This doesn't exist. Like, what are you doing? And then I turned to my coworker and I said, did you give me the right argument? It's not working. And then he said, oh, it should work. And then I looked over at his screen and there's an AI chat thing. And then I look at him and I go, did you just give me an AI output thing? And then he looked at me sheepishly and he goes, oh yeah, I mean, like it is AI. It could totally be making things up. And I go, then tell me that. Why? Why would you possibly, like what on earth would make you take this thing and go, oh yeah, I'm just gonna blindly believe everything that I've read on the internet? And by read on the internet, I mean like that something just gave me. And I'm like, you don't even do that when I give you something that I wrote myself. I mean, sure, the AI doesn't have to, whatever. But there's this concept of de-skilling that is kind of happening, where it turns out that humans have certain sets of skills that are advanced, certain sets of capabilities, and they develop these capabilities, and there's not the entire culture, institutional knowledges of a culture. And everybody in that culture that needs that skill gets it. And it's really, really cool. So, for example, there was a town in the United States that for about 50 years, the vast majority of people in the town were born deaf. Nobody knew why. But it turns out that that town invented its own sign language. And everybody in the town could sign because it was just assumed you probably needed to know how to do that because everybody was deaf, except for people born outside this 50-year time range. And then that stopped happening. And then everybody forgot how to sign because they were like, oh, we don't need this anymore. But also it turns out this is also how language evolves. And this is also how certain other things evolve. Like, I'm going to do a sign in sign language, and I'm going to see if you can figure out what the sign is. So for those of you who are old and traumatized by the weary years, remember, you remember that. Everybody else who's not old and weary and traumatized and doesn't wake up with back pain, good for you. You just do that. It's kind of nice. We don't know what rotary dials are anymore. Nobody even knows that like one of the reasons why 911's number is because that's really fast. That's one of the reasons why it's 911 instead of, like 876. But this de-skilling thing, this concept of you don't need these skills anymore, so you're just going to kind of forget them, it's pervasive. It doesn't have to be bad. But one of the things that's really, really important here is what we're seeing throughout the industry, particularly when it comes to AI and these thought workers, is we spent decades just not calling ourselves thought workers. We spent decades saying, hey, what if, hear me out, what if we figured out how to turn our brain off and just do the ticket? And don't think about it, just implement it. Don't think about it, and we lose this notion of critical thinking in all of our thought work. And then we think, oh, we can replace these non-thought workers with things that don't think. And that would be true if we weren't thought workers. But we are. We do this knowledge work thing. We literally get paid to take our brainstem and plug it into a computer and then get traumatized by outages. Like, that's the whole thing. And maybe we shouldn't forget that.
So, as Hazel said, AI adds layers of complexity rather than simplifying the system understanding. So I think I'm going to with quite a bit of theory, so let me share some practical examples. So I think all of you know about the Google Cloud buckets, okay? And I think you know that when we are doing testing, we always want to use production data for testing because that is how we can basically make inferences. So we have like a production Google Cloud and the test environment, and we have like hundreds of buckets. So the developer who wanted to do the testing, he copied a whole lot of production data into test bucket. And then he forgot to delete it. Now Google has recently come up with something known as a soft delete retention policy. What it means is that if you delete something in a bucket, by default, it will retain it for 7 days. And in production, this is very helpful because I remember even as an experienced SRE, I accidentally overwrote a bucket using a Spark code. But thankfully, because of this ability to recover the data that the S3 bucket provided, I was able to recover all the data. But now, in this Google case, I'm talking about the development environment. Why would I want a retention policy in a development environment? It just doesn't make sense. So when the cost snowballed, my manager asked me to look into why the bucket is costing so much. So then I went to the GPT and I told him, just write a small Python script that lists the top 10 buckets by the sizes and the top 10 folders within it. You think it should be a 15-minute task, right? Let me tell you how long it took. Now, the challenge is that the soft delete retention policy that was recently introduced, okay, there is no Python SDK documentation for it. In the official Google documentation also, you cannot find the Python SDK documentation. It only has like the call command and other things, but nothing about Python. So the AI tool, now I did not know this. I actually found it. So one day I told that it confidently told me that to use this method. And I blindly trusted it. I used the method 1, it did not work. Then it told me to use method 2, it did not work. Then it told me to do method 3, it did not work. Then I again went to it, it told me to use method 1 again. Then method 2, method 3, and it went on a loop. And it was horrible, and I was like, why is such a simple thing taking so much time? And that's when I found that there is no documentation. So since there is no training dataset, no documentation, it couldn't really figure out the exact API call to use for Python. So how did I fix this then? I went to the source code. From the source code, a Go developer always writes some test cases. From the test cases, I found the API call. I took it and then I told GPT, see, this is the test case. Now generate the equivalent Python code. And finally, it generated a very accurate. So the AI system is a very wonderful tool, but it sort of needs a continuous human intervention. It is sort of what you have like in the data structures and the algorithms interview, where you start with a brute force and then step by step you go on optimizing. This is how our interaction as SRE we should be interacting with AI. And so AI is supposed to enhance observability and explainability and not replace them. And lastly, the correlation is not necessarily equal to causation. AI often flags patterns without understanding why they exist, leading to misdiagnosed issues. Okay, so now I'm going to talk about some biases. Some are related to SRE, some are generic. So if you go to an AI tool and ask it to generate an image of a person who is writing with a left hand, it invariably generates an image of a person writing with a right hand, because the entire training data set is used as a right-handed. The second thing is, I came from India. So from India to San Francisco, I came via Frankfurt. Now, Frankfurt, an Indian citizen needs a transit visa for Frankfurt unless they have a USA visa. So I have a US visa, which is why I'm here, so I could transit to Frankfurt. Now, the airlines also had to tie up with Air Canada. So I asked GPT if I could transit to Canada. It said yes. If I have a US visa, I could transit to Canada. I then asked her 100% sure, and then it corrected, saying no, an Indian citizen cannot transit to Canada even if they have a valid US visa. So the way the AI responds, you have to continuously tune it. And then, so we have like a large number of Cassandra nodes. They all run on EC2, and it is like a self-managed cluster. So there is a difference between self-managed and like AWS managed is that a self-managed gives you like a lot of raw power. Like think about the Formula 1 car. A Formula 1 car is never fully automatic. It is always sort of semi-automatic because it gives the driver the power. So same way, if you really understand your system very well, then you sort of try and build sort of what you say self-managed system, because you could actually scale down cost and boost up performance that way. So here, it's not it's not abnormal for Cassandra to run actually about 90% memory, because it uses the full heap that we allocate. So when an AI system was brought in, it actually said that this Cassandra cluster is horrible and it's underperforming, but actually it was performing very well. And next, I actually want you to give an example of what happens with opacity. So we hire the person, we have like a lot of pipelines and a lot of stuff, and we hire the person, an SRE, and we ask him to optimize system. So I have a very huge elastic stack that I optimize a while back. I'll come to the context later, but now this SRE, he just become the elastic stack. And then whatever is there, he just feeds it into the GPT. The GPT gave him so many very good responses, and then he began detailing documentation, and he spent 1 week making a super detailed Confluence page of how to optimize Elasticsearch. And then he came and told me, this is my first task. Can you just imagine what I had to do? I had to discard the whole 1 week of work, because it was not at all applicable to this Elasticsearch system in the first place. The AI never explained in detail the reasoning behind this. So on this particular Elastic system, a while back my manager came and told me that the business priorities have changed. This Elasticsearch is to be put on, keep lights on. No new development, no new maintenance, no new money. And it is costing $12,000 per month, make it $4,000 per month. You have no chance to argue with your boss. You just have to do it. So then I went back to my drawing board. So I shut off all the replicas. You think doing away with the replica in a production system is a horrible thing. It is horrible, but it depends. Okay? I had a time-based index. So all my data was going into today's index. So yesterday's index did not get any data. So what I did is I compacted it, made it read-only, and snapshotted it. So then I did not need any replica for yesterday's or previous indexes, because if something data loss were to happen, I could instantly recover. Okay, and then what I did is monthly indices, my device indices are merged into monthly, my monthly into yearly. So like that, a lot of optimization was done. So the yearly index could have about 100 stars. The monthly index had about 15 stars. And the daily index had about 1 star and 1 replica. Because today's index might crash, I need a replica, it's not snapshot. So on this context aware, the AI tool wasn't aware. This system is actually the most performant, and I run without any downtime to this day, but the AI tool flagged it as the most worst Elasticsearch system. So human intervention, context, and AI is a tool, and it has to be used with human collaboration. Okay, so the last slide for me before Hazel takes over. So the AI-driven observability, alerting, incident response are still evolving, and the AI recommendations become harder to challenge because most organizations are relying on automated decision-making. But as I said, you need human in the loop, not fully autonomous system. So how do we counter AI failures and make it work for us? And that's where system thinking and resiliency engineering comes in, which Hazel will take you to.
So a lot of what we do is this systems thinking. It's really, the whole thing boils down to figuring out how to do the non-obvious thing, figuring out how to take these complex stuff and make it workable. But when the system is kind of broken, kind of poisoned, kind of whatever, how do you do the systems thinking? So I actually have a picture here of the Princess Bride, and this is one of my favorite scenes in it. It's where, he, Wesley, is capturing and rescuing the princess. And when he rescues the princess, he plays this game of, oh, if the person takes this poison vial, you die or I do. And they do this roulette kind of game. And then she goes, what? Oh no. Wait, it was yours that was poisoned the whole time? And then he goes, don't be silly. I poisoned both of them. And in fact, not even that. It's, if you take this and step back, he's going, you know what? I fucked it up on purpose. For the purpose of understanding things, of actually getting to where we needed to go. Why try and avoid errors when you can get really, really good at solving errors? You're not going to have a perfect system. It's not going to be fully functional anyway. AI or not, poison or not. Just get really good at drinking poison. Just guzzle that shit down, you know? Why do you think we all have a drinking problem? So, when you think of a resilient system, the system is socio-technical. You have the people, you have the tools, you have the actual computers, you have the interactions of all these things. And what does it mean for a system to be resilient? A lot of people might go, oh, you know, uptime. Some people might go, MTTR, and those people are shunned. But when you take this whole thing, you go, okay, what is resilience really? Resilience is, in a lot of ways, about being able to work with what you have and to continue to make progress with the system, kind of despite what happens. I mean, none of us blindly, without reservation, trust our own code. None of us trust our, coworkers' code. We look at it together, we verify, we check, and we think about it. We should probably do that with our tools as well, because as we all know, have we ever spent a time when we've debugged something and all of a sudden it turns out either the tool maybe lied to us or the tool itself was broken, or what's the difference? When you have these resilience concepts, you need the resilient tools. The tools themselves have to be resilient, but how you use them, that process of using them, also needs to be resilient. You can't just pick up something and go, oh, this hammer will absolutely work for anything that I use it on, and then just smash that screw into a wall. You might have to actually think about it. And that's okay, because that's what we do. We think about things. We work with it. We make stuff work, even if it's hard. Oops. Other button. There we go. One of the coolest things about making things work and understanding them is, so humans work in a really, really cool way. And we are special in this regard in that we think we're special and we're actually not. But the other way that we're special in this regard is tools are literally, if you look sociologically at how humans work, tools are how we understand the world. We look at the world, we look at the environment, and we build a tool to help us understand the environment. It's deeply encoded in our evolution to do that. That's how we do things. That's how we learn. That's how we function. And not only do you do that, but we then have this really iterative thing going on where I build a tool and someone goes, ooh, that's cool. I'm going to learn how to build that same tool. Sometimes we forget to, credit people for that. We're working on it. It's a bug. But we go, oh, I'm going to take this tool. I'm going to learn it. I'm going to understand it. And then, you know what? My context, my need, this is a little different, so I'm going to tweak it. But I'm going to change a little bit. I'm going to make this tool work for me. I'm going to make this process work for me. I'm going to make this workflow work for me. And you do this kind of crude, sloppy sort of, oh, I took the tool and then I just JB welded some stuff on the side of it, and now it does logs and other logs. And then you go over here and someone else goes, ooh, that's cool. And just keep doing this process evolution thing, this tool evolution thing. And if you want to teach other people how to do this, how to do this thing, you have a process. Like, for example, Alex Hidalgo was telling me the other day about how he was one of the first people to take like a flow chart and write down no, what's wrong? It's DNS. No, it's not. No, screw you, it's DNS. Like, go fix it. And then you have this flow chart of debugging. That's a process. That's how you teach learning. That's how you teach investigations. How you teach systems thinking. We already have that. And if the system in the tool, in the flowchart, in the process needs to now include, and the tool is a little fuzzy, it's a little wonky, it's a little, more unpredictable than you may be used to, but it's flexible in other ways. Well, now you just have to put that into your process and you're fine. So if you think of maybe thinking of like the golden signals, because people have asked questions about that. We have these normal systems. We have these magical golden signals. We have these, if you don't know what you're doing, start here. And then we have the AI side of things, where you have, the normal one is latency, traffic, errors, and saturation. The AI ones are, latency, traffic, errors, and saturation. What changed? Well, okay, so maybe traffic is kind of more about like tokens or whatever the hell that is. Maybe the error is more like, oh, is your context right? Is the context being dropped? Is maybe you need to worry about like model collapse, but the fundamentals, if you dig just like one layer deeper, different shape, same stuff. And in fact, isn't that what we keep telling everybody? Every time they invent a brand new thing, and you're like, you just reinvented Nagios, and I hate you for that. And every 3 years, we have the same thing again. It's fine. Because it turns out, no matter what happens, what keeps happening over and over and over again, the fundamental truth is systems thinking was always messy and human. The tools that you have to build to understand something, they're janky, they're brittle, they're weird. The better your system is, the more fucked up you have to explain how your tooling works. Like, the more weird, the more nonsense you have going on behind the scenes, the more polished the production. Have you ever seen Broadway or seen like this magical theatrical production? You're like, this is beautiful, this is perfect. And then everybody's like, don't look behind the curtain. You want to know why? It's all the trauma of the theater kids who said, I could have been an SRE instead. And instead, I was like, ugh, and they're all running around, they're crying, like, the lights are broken, everything, like the wig just got glued on last minute. And they're like, I'm going to have to shave your head later. They're like, I don't care, just put it on. The process is really messy. It always was, it always will be. And that's fine. Because we have this irony. There's a famous paper of, the ironies of automation, and it was written in the 1970s by a woman, which is why nobody knows about it. But the paper talks about the more you automate a system, the better you make it. It turns out less people need to run it, but those people need to know a lot more. They need to be a lot more sophisticated in how they mess with the system. Like, just imagine cars back in the 1940s. Those things were dead simple. You can take 4 different tools, open the whole thing apart, put it back together in about 2 days with a paper manual. Now, they're like, oh yes, you need these 87 different wrenches, these 14 different gauges, 16 different computers to unplug everything, otherwise your blinker fluid won't work. And then they're like, no, blinker fluid doesn't exist. And they're like, no, you can thank Tesla for that one. And it's going to keep happening. The more complex things are, the more fuzzy they are, the more adaptable and malleable they are, the harder it's going to be to kind of work with it. The weirder the shape's going to be at the end of it, but it's just going to kind of work out pretty well. As long as you remember, then you just have to think about the entire system altogether. Right. You have 10 seconds. Just kidding.
So we come to the concluding slide of our talk. You have all heard about the story of 9-9 in SRE engineering, but I'm going to tell you a different story about 3-9. So there was once a ship whose engine failed, and the owner of the ship, he tried to hire so many specialist engineers. But one after another engineer tried, but no engineer, no expert could fix the ship's engine. So then there was one old man, and the ship owner called him, and the old man came with a big set of tools. And then he went about, he began tapping everything and listening in the ship's engine where the noise was coming. After inspecting for a couple of minutes, he went to his big toolkit and he took out a hammer. He walked with the hammer, he went to a place and just stabbed the hammer twice, and the engine sprang to life. Something that nobody was able to fix for a couple of days. Then he went home and he sent a bill of $1,000 to the ship's owner. The ship's owner was like, tapping with a hammer, how can it cost $1,000? Can you send me an itemized bill, please? The man sent an itemized bill that read, tapping with the hammer, $1. Knowing where to tap, $999. So this is an essence about the SRE engineering. The future just isn't about building a better AI, but it's about building better engineers who can work in correlation with AI. Thank you.